Welcome to COM 200. I find a great deal of pleasure that the track that I and my homies work in is labeled COM. The irony is not lost on me. Speaking of naming things, you know, back in the COM era, which some of you guys were part of, you know, the marketing folks had this wonderful habit of renaming the same technology over and over and over and over again every year. You know, WinDNA, digital nervous system, oh my God. And, you know, Chris Ann and I did this lap yesterday, and several people have asked me, you know, you guys call it Indigo and Avalon still. You don't call it those other names. Well, let me explain why. Stuart Solarier, would you be so kind as to come up here so people can see you? Just walk up here, please, 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 please. Give it up for Stuart. Stuart, tilt your head back. Stuart's beard is not WCF colored. It is indigo colored. It is in honor of Stuart that I still call it indigo. Thank you very much. Leave Stuart. Get off, get off. So, what we're going to do is kind of take a lap around a bunch of technologies that the team I work on builds. We're going to look at Indigo. We're also going to look at how WWF interacts with this world. We're going to look at how the identity space, which is also part of my team, works. So we're just going to see a whole bunch of technology. I think you're going to find some common themes, and I'm going to definitely try and make the talk interesting. Now, Steve Schwartz, a good friend of mine, a lot of you guys know Steve. Steve's a very colorful character. Steve was an economics graduate student. And Steve used to talk about economics professors starting every economics talk with a French philosophy lecture, right? They would talk about the esoterics, the motivations for everything. And this talk was at risk of becoming a French philosophy talk. I had grandiose visions of, you know, all kinds of esoterica, but I decided instead what I would do is mostly code, because code is less esoteric than pontification. So, without further ado, let's talk about why we're here. If you look at the body of work that the team I'm a member of works on, and the stuff we're going to code up, the motivation, the problems we're trying to solve are these three. Software needs to be more transparent, right? We've seen over the past decade, 2 decades maybe now, you know, the increasing importance of being able to look at an application, look at a component, look at a piece of software, and understand more about it, right? Back when I started programming on Windows, transparency meant dump bin, right? Dump bin was this wonderful SDK tool that allowed me to see the cough symbols that were exported from a DLL. It was lovely. They all had underbars and @ signs with the stack size after them. And that told me a lot about how that DLL worked. It was really cool. Turns out that wasn't enough. People weren't satisfied with that, so we've been chasing after this dream of making software more and more transparent so that more and more people are able to actually understand what's going on. Another problem, you know, we look at, and we certainly face it inside of Microsoft, is that software needs to be more flexible, right? We learned a lot of lessons in the 1990s with COM. Right? COM, on the one hand, giveth flexibility by adding dynamic loading to C++, but then it taketh away flexibility with the immutable interface concept and the fact that we had these stack frames, which were a very, very tight binary format, which fell over as soon as you changed something. So we got to solve that problem. We're working, spending a lot of time and energy trying to solve that problem. And then this last one is a little more recent, especially for me personally, because I'm pretty much a plumber at heart. At the end of the day, we need to grow the tent, right? Having software written by people who come to PDC is super important. And it will always be the case that you, the people who show up to PDC, will understand the abstractions, the logic, the conceptual goop that we use to take our ideas and turn them into bits and bytes. However, I want to see more people writing software. I want to see people who know things about stuff other than software building things, right? Be they people who understand some business domain, or people who understand the arts, or people who understand literature, I'd love to see those people writing applications too. So if we just keep telling everyone C# is the answer, which, by the way, I love C#. I will probably program in C# till the day I die. Okay, maybe not. But I will program in C# as long as it's what pays my bills, to be clear. C# is a lovely language, but my mom is never going to learn it. And more importantly, my brother's never going to learn it, right? And my brother's got some great software in him. But if I have to force him to understand case sensitivity, curly braces, blah, 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 we're lost. And so the whole idea is to get more and more software out there. And so to do that, we need to make it so you can write software closer to the problem domain. That doesn't mean we dumb it down. What it means is we change the ideas that you work in terms of, right? The difference between a class and an interface is only interesting to people who come to PDC. And me. I love it. However, if my brother needs to understand that, we're lost. So the goal is make software more transparent so we can understand it better, make it more flexible so we can change it to adapt to the world around us, and finally to raise the abstraction bar so that more people can write software, and that really gives us more opportunity because more people will use our bits, right? Right now we're just selling to each other, right? You got control vendor A selling to control consumer B, you know, it's a tiny little world. There's tons of people on this planet that, you know, you want their money, right? Or certainly you want them to increase the quality of life on this planet. So, let's go ahead and get started. We're going to start off by talking about how we make software work together. And to help me through this trek, this journey, I'm going to bring up Mike Vernal from the Indigo team. Give it up for Mike.
Yeah. Is this on? Is this on?
I believe it is on, Mike.
Fantastic. Thank you, Don.
Don't touch the machine. Mike, you are a monkey. You are the code monkey for this part of the talk.
Fantastic.
Your job is to remove all free will. You exist to be just a vessel for my own will. Does that make sense?
I don't think you've known me very long, but sure.
Well, we'll find out. What I would like you to do is advance to the next slide. We're going to start by talking about how programs talk to one another, how we make programs work together. Laurie Bixhorn, one of our product management guys on Indigo, asked me, what is the essence of Indigo? What is Indigo all about? And I basically said, it's lubrication for software. It exists so I can remove the friction between two moving parts and more easily adapt them. And the way we're able to achieve that in Indigo is by embracing this notion of protocol-based integration. Now, I know since this last PDC we had 2 years ago, the whole industry is saying, SOA this, SOA that, SOA whatever. Well, SOA what, right? The important bit of information is that we're integrating software based on the exchange of data, of messages, full stop. Protocol-based integration simply means I have a message, I give it to you. The message is the truth, because that's what we're actually exchanging. My interpretation and your interpretation of the message are fiction. They are subjective interpretation. The only thing that matters in this world of service-oriented computing or protocol-based integration is the existence and format of the message. So I have prepared this slide. A message is an XML-compatible unit of information exchanged by programs. And I have come up with, I believe, the most ideal picture of a message in the form of haiku. And this entire talk will be given in terms of haiku. Message, oh, actually, Mike, would you like to read the haiku, or would you like me to?
Sure, I will try. You can have the next one. Message, oh message, the truth is on the wire. There is nothing else. Thank you.
Great. Now, to reinforce this, what I'd like to do is write some code. Mike, you may now relax. Your will is coming back. Why don't you step up to the machine and bring up America and the world's favorite development environment?
Yes.
Visual Studio. Whatever you feel comfortable doing. What I'd like you to do is, what we're going to do is write a little program to work with messages. Right? I want to just take away all the mystery. Oh, by the way, I'm going to tell you. we're going to write a series of highly impractical programs. I am not going to show you how to build the Contoso to Fabricam federated B2B application. I'm sorry, I don't know how to do that kind of talk. Instead, we're going to write the most bizarre, odd, yet illustrative code I can imagine. Okay? So do not expect to get practical information from this. It's really just about figuring out how this stuff works. Okay? So, without further ado, will you make us a console application, and we're going to use a little bit of that new integrated query stuff, even though we're not going to use a lot of it. Yes. Hit OK. That's a normal thing. Now, because we are going to be using a variety of technologies in the pantheon of our connected systems division, I'd like to start by adding a few DLLs. So I'd like you to add system.serviceModel. This is where the vast majority of Indigo lives. System.serviceModel is both an assembly and a namespace. I would also like you to bring in system.runtime.serialization. This is where a lot of our formatting and contract system lives. And then finally, I'd like you to bring in system.security.authorization, because this is where our security system primarily lives. Between these three DLLs, you got the lion's share of what you need to do with Indigo. We got a lot of auxiliary ones that typically just get loaded in because they're providers or transports. But this is where the real meat of the system is. Have you done that now, Mike?
Yes.
Will you open up your program? So we're going to write console apps because I'm an old school 80s guy. That's when I really learned how to program. And when I started programming, we used consoles. Right? So what we're going to do is I want to take a message into this program. We're going to write a service. We're going to write a service-oriented application. So to apply service-oriented principles, we're going to get a message. And where are we going to get the message from in a console app? Standard in. Standard in, baby. So what I'd like you to do is create a message. So we're going to use message. Message is a built-in type in Indigo. If we had to ditch all, if we were had to cut features, and we just had to cut dramatically, and we had to cut 98% of Indigo to get it out the door, which by the way is not the case, but if that were the case, this would be the one type I can guarantee you we would keep. Because this is the heart of Indigo. So we're going to declare a message. Why don't you call it request? And the way we get messages is we have this little factory function called message.createMessage. And message.createMessage has, I think, 78 overloads now. What's it up to now, Mike?
Oh, it's only 20.
It's only 20, okay. One of them happens to be an XML reader. So the XML I/O system has been system.xml. So if you could go ahead and say, new XML text reader, console.in, oh, and of course, bring in the namespace. Close, close. Oh, when we read a message in, here's an interesting thing that actually bites me from time to time. In general, when we're doing messaging, we're getting messages from all over the planet, and sometimes from people I don't trust, or I don't trust a lot. And so there's a risk that they could just send me an arbitrarily large message and give me a denial of service attack. Just start consuming buffer space. So message.createMessage, and the low-level infrastructure that we use in Indigo to take advantage of this, has an upper bound on how much we'll actually consume off the wire before we say the message is too big. Now, I trust you, Mike. You're my brother. So we'll go ahead and say int.maxValue. Don't you dare do this in a real application. I expect you to use the smallest number possible plus 1 in case you have a boundary condition error. Now, do we have the program? I would like to see the message. Would you be so kind as to do a console.writeLine of the message? I love that. Will you build it? Did it build?
Yes.
So why don't you go to a shell. We've got a shell running. Any one of those shells will do. And let's make up a message. So how are we going to make up a message for feeding it into console.readline, that whole thing? We're going to need a new text file. So why don't we go ahead and make a new, are you going to actually type it, are you going to type in a message from standard in, like you tried to the other night? That was so fun.
Yeah.
Yeah. Let's type in a message into a text file so we can play it over and over again. So why don't you go and make a new XML file? Right? Remember the meme that a message is an XML compatible unit of interchange between applications. So we're going to make a new XML file. And by default in Indigo, we use SOAP. Don't have to, but that's the default we assume. So why don't you go ahead and set up the encoding to be what this thing will save it as. And let's make a new SOAP envelope. Cool. So we're going to need s:\envelope, XML and s:\s equals, and notice, Visual Studio is SOAP enabled. The schema for SOAP is part of the XML schema cache for Visual Studio. So for those of you who like to build your applications by typing in the messages and then sending them, we got you covered. Built-in, out-of-the-box support. In fact, I guess this makes Visual Studio 2005 service-oriented. Great. Now, SOAP, for those of you who've never seen it before, it's just like HTML, but for software. HTML, you got your headers and your body. Headers is just for all the crap around you, and the body's what you really care about. Well, guess what? With Envelope, we just cloned HTML and made it uppercase, right? So just think HTML for software. Great. So we got a body. Looks good, looks lovely. That looks like a legal message. Did you save it?
Yes.
Would you be so kind as to use the service orchestration tool that we ship with Windows, which is cmd.exe? So we're going to run the program. We're going to pipe in request.xml. Wow. Give it up for Mike. You got his first program working. Now, notice that we were able to just feed it in there. I didn't do any add reference. My client, which is cmd.exe, which, by the way, shipped ages ago, was able to just cons up a message and send it. I don't need to share any DLLs with that program. I don't need to share a common platform, a common runtime. I just need to be able to formulate a text file and stick it in there, and he'll do his work. That's such an important distinction between this approach and what we tried with COM. Huge, huge, huge. And what we tried with Java. And to a degree, what we tried with the CLR. Right? This is a much more flexible integration style. Now, before you leave this window, I noticed something odd. Look at the body. If you look at the message when we replayed it to the output window, the body is streamed. By default in Indigo, at the lowest level of the messaging stack, we do not buffer the body of the message. That is, we leave it on the wire and wait for you to consume it. Right? Again, this gives us a much better performance characteristic. It allows us to do lots of things much more flexibly. If I wanted to print out the body, we'll see how to do that in just a second. Now, we've consumed the message. In Indigo, even though we don't force you to do XML on the wire, we have binary encodings. We don't force you to do SOAP. If you're doing XML, we have POX encodings. One thing we kind of assume is that for us to route the message efficiently within the app domain, once we suck it in off the wire, that we want a key of simple value we can test against, that's a string, that we can use to say, I think this message means that. So we have this notion of an action that's affiliated with every message. And by right now, the action would be null. So what I'd like you to do, Mike, is go back to the XML, and let's add an action. So turns out we got together with our friends at IBM and BEA and SAP and everybody else on the planet and wrote this little spec called WS addressing. And pretty much, it's getting deployed pretty broadly now. W3C is almost done with it. And there's the namespace for WS addressing. What we're going to do is add a software header, that is, a header that's just about the low-level plumbing, that says, here's what this message means. Why don't we pick an action URI? Please use your creativity here, Mike. I trust you to go nuts, man. This is your window for monkey creativity. You are such a creative monkey. Love it. Cool. So now what I'd like you to do, Mike, is you save the message. Just run your program again. Don't change the program. Just run it. See what happens. Cool. So notice the action got picked up by the plumbing, and it's now part of the message in our in-memory model. But more importantly, can you go back to the code now? And instead of right-lining request, just right-line request dot header dot action. We take action as there. It's something that's a first-class concept in our messaging model. We happen to use WS addressing when we use SOAP. We use a variety of other things when we use other kinds of transports and formats. But we have this normalizing concept of a single key that we can then use to route the message based on what kind of action is expected. Did you run it?
I have not yet.
So notice now, the messaging system has shredded that piece out for us and just shown us exactly what we want. Y'all got it? Cool. Now, we've seen message input. Most services, and certainly we're writing a wonderful service here, has to output the message somehow. So why don't we do this? Would you be so kind as to go back to our program? We're going to get really fancy and elaborate here. We're going to make this a real app. Now we're in that Contoso space. I can feel it. What I'd like you to do is first test the action against the action value you just typed. So if request.headers.action equals whatever it was you typed a few minutes ago. If it's that, we're going to do something. If it's not that, in fact, I want you to declare yourself a variable called reply outside of the scope, because we're going to just have a little pseudo switch statement here. Message reply equals no, and put an else clause in there. And if it's not the action we expect, then you've sent me the wrong kind of message. So what I'm going to do is send you back a different kind of message that tells you something screwed up. And it turns out we have a common faulting system, a way of indicating that something went wrong, called a fault. So what we're going to do is create a false message. And Mike, this API is one only a mother could love. So I have taken the liberty to put it into a snippet. Fortunately, Mike owns this feature in Indigo, and we haven't shipped yet. So Mike now has high motivation to make it a beautiful, loving piece of API. And you want to set that to reply.
Just to be clear, my mother does actually love this API.
I know she does. So let's take a look at this code for a second. We've called create message. We've passed in the version of the messaging protocols we're using. So we just took the version of SOAP and all the other crazy protocols we got on the input, and we just used it in the output. We then created a data structure from hell, which we don't want to think about right now. Now, let's go into our real code. What we want to do is, since we did this, Chris and I and Anders and Scott did this lap yesterday. I'm sure a few of you guys saw it. I'm going to show you exactly how we did it. So why don't we go ahead and rewrite that query. So bring in system.diagnostics. So why don't you go ahead and write the query that conses up the XML we want. So query equals new X elements, open paren processes, tab, tab, tab. Actually, once you hit return after the equals sign, that makes it indent really nicely.
Hit return after the what?
Right after the equals sign. Right there.
Sure.
Yeah. Cool. Now return tab. From P in process.get processes, select new X element, process data, and then let's do name and working set. So this is more or less the query we worked with yesterday, right? And I think, we wrote this more or less by hand. We did some RSS stuff because it was trendy, right? But you get the point. Working sets. Good, 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 close, semicolon. Great. Now, what we'd like to do is take that XML. So I've just got a piece of XML. I got an XML query in memory. I'd like to take that XML and just send it out in a message. And here's the interesting thing. Link hasn't shipped. I mean, it really hasn't shipped. It's not going to ship when we ship. We will ship before they did. We cannot take a dependency on Link. There's no way we can build in support for Link into the Indigo in RV1, because Link doesn't happen until after RV1, right? Just think about it. We're not clairvoyant, right? Besides, resolving the reference for the assembly would be a real bitch. So what we're going to do is we're going to write the code that makes it work with this. We embrace XML in Indigo. However, we let you build your own XML programming models. And what we're going to do is write the adapter that takes Link and makes it work with Indigo. So we have this little piece of interface, this abstraction called a body writer. So I want you to write a public class xBodyWriter. And this is the exact code that Chris and I used yesterday. Derives from BodyWriter, which is a built-in piece of machinery in Indigo. And it's got one method called onWriteBodyContents. So what we're going to do is hold an X element here. Go ahead and initialize it in your constructor. Oops. There you go. And now, to make the actual bridge, we just simply, in this WriteBodyContents, call element.write, it's actually write to, writer. Y'all see that? So we can't ship this code in Indigo because we can't take a dependency on link. But you can write it, and I'm sure we'll figure out some way. We'll have 25 million meetings, and we'll figure out who's going to ship these 8 lines of code, and then it'll get out to you as part of the platform. But even if we don't, even if it takes 25 million and 1 meetings, and we don't have time for the last one, you can just write the 5 lines of code. It's no big deal. Okay? Cool. So why don't we go ahead now and return a message? So why don't we go ahead and say reply equals message.createMessage. And what we want to do here is use the message version for the request. And we want to use an action, I believe, as the next argument. So pick an action URI that you want the receiver to get. Cool. And then finally, go ahead and put in your new Bex body writer. Cool. You got the reply, go next, down, 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 down. Now I want you to go ahead and write, instead of that write line, nuke that write line, and do the message, or it should be reply.write to. Write message. New XML text writer, console.out. And then formatting equals formatting.indented. So we can make it look really pretty. Cool. Great. Why don't you run your app now? Body writer. Oh, damn, how many times? Yes, that's such an impossible thing to remember. The constructor of body writer requires a parameter telling it whether you were doing buffered messaging or streaming messaging. We forgot to set it, so we got slapped down by the compiler. The compiler is such a unforgiving mistress, yes. Now, next, run. So notice that we have a SOAP envelope with our XML in it, and we're all done. Make sense? Cool. Would you all tab back to the slides real quickly? Next slide. Indigo is based, we use messages between applications to make things work, but so that we can have better transparency into our software, we have these XML-compatible descriptions of the set of legal message exchanges, which we call a contract. And we have contracts so that I can walk up to a piece of software and figure out what are the gazintas and what are the gazatas. That's why they exist. Mike, would you like to do this next piece? Go, please.
To marry our apps, your contract or my contract, both color the dance.
Thank you, Mike. Give it up for Mike. There's something there. Here's the interesting thing. In COM and in the CLR, we have a single type that both sides of the marriage must share. We have this notion of strong type unification based on nominal types in the CLR. That is, the type used by the server and the type used by the client have to be not just equivalent, but identical. That is, there has to be one loaded instance of it in memory. We're thinking about building distributed systems now, right? The thought of having shared state that must be kept in lockstep synchronization, we know causes us no end of havoc in the world of data access. Why would it be any different in this kind of data access? So the notion in this service-oriented, protocol-based integration world is there are actually two contracts. The contract of the service and the contract of the consumer. And they do not need to be identical. They simply need to be compatible. That is, each contract identifies a universe of legal message exchanges. To know whether an initiator can talk to a service, all I need to do is the Venn diagram. There's my Venn diagram. And if the Venn diagram has a non-empty intersection, what do we know? There's a chance. Doesn't mean it's necessarily going to work, but it might work. If the Venn diagram has an empty intersection, what do we know? Don't bother trying. You got it? That's all we know. So why don't we go ahead and use the contract system of Indigo? Mike, would you be so kind as to go back to Visual Studio? Make me a new CS file. Call it contractor. We'll call it whatever you want. But make a new CS file. That's all I care. Now, Mike and I believe strongly in the principles of contract-first development. Indigo's a big tent. You can do code first or contract first. You pick. We support them all. You want to do anything first. I don't know. Pick your nose first. We'll do that one too. Right? If there's a big wave and there's people spending money on it, pick your nose first is going to be in Indigo. I can promise you now. Now, what I'd like you to do is, we wrote our contract in the industry standard interchange format of choice called WSDL. We wrote the WSDL file. It's in the file system. Would you be so kind as to open it up in some file? You can use Notepad or whatever you need to do. Copy and paste it into the CS file. I'm going to show you a great feature of Visual Studio 2005, part of their whole service-oriented initiative. Right? I can take any WSDL file anywhere on the planet and paste it into a C# file. And watch, here's how you support WSDL. All the way to the bottom, all the way to the bottom. Yes, it works. This file now compiles, and I have full support for WSDL. Yeah, we have some tools to do more with it, but hey, you know, whatever. The tool we could use is serviceutil.exe, a name only a mother could love again. But what we're going to do is I'm going to turn Mike into the human service util. Right? So I'm going to have Mike play the role. He's going to do an interpretive dance where he imitates the service util tool. The contract system of this service-oriented world is simple. We got two kinds of contracts: structural contracts and behavioral contracts. We're going to do the structural contracts first. The very first construct in this file, why don't you give it your if false, is a schema. Now that first piece of array of process data, get rid of it, we don't need it. Right? That's just goop. The thing we do care about is that process data. Right? So why don't you go ahead and write what we call a data contract, which is effectively a simple schema language which we interleave into our code to allow us to project a static type on top of the flexible XML. So go ahead and say, turn it into a class definition. Looks good. You know, service util goes a little faster than you, Mike. I think we should ship that too. Unless you're willing to go from town to town, translating WSDL to C#.
Like to travel.
There's good money in that kind of work, you know. Public string name, data member, public int working set. Cool. And now get rid of all that XML goop. Cool. So we have the data, the process data schematized now, both in XML schema and in CLR metadata, so we can program against it. Now, the next thing you'll see in the WSDL file is this notion of a message. Indigo is about message exchanges. WSDL is about message exchanges. Why don't you go ahead and port those two characters over to CLR metadata. So what we're going to do is say public class process message. And this time, instead of saying data contract, we're going to say message contract. Because we're going to say this is not just a structured piece of information. It has the additional characteristics that it's going to be used as a top-level message. That is, it has headers, it has bodies, it understands things like the SOAP processing model, must understand, blah, blah, blah. And instead of saying data member, what we're going to do is say message body. Everything okay, Mike?
Yes. Do you want me to
do the next one?
Okay.
Yeah. Now, it turns out, I know Mike. Mike's a very clever guy. Mike, you went to school in Cambridge, Mass, so automatically you're in my top tier of smart people on the planet. Did you go to MIT or did you go to that community college nearby where they teach business?
I went to the community college.
Okay. But you hung out with a lot of MIT folks, I'm sure.
I avoided them like the plague.
Some of your best friends, you know. So why don't you go ahead and make this a process data array? So again, this is what service util will do for us by machine. Make sense? Cool. Now, because we are running a little bit short on time, why don't we go ahead and write the behavioral contract while we're here? So what we're going to do is take that process management contract and turn it into what we call a service contract. So we just saw the structural contract system. Now we're going to see the behavioral contracts. Behavioral contracts are marked up using service contract. They correspond to WSDL port types. And what we're going to do is have a single operation. And I can decide whether I want it to be synchronous or asynchronous. WSDL is silent on how you do local programming language mappings, as it should be. And in Indigo, one side can think it's synchronous, the other side can think it's async. So why don't we go ahead and make the client async and the server sync? Is that all okay with you guys? So to make the client async, we're going to go ahead and use the standard begin-end pattern with async result that everybody knows and admires, if not loves. And we'll define the contract in terms of that. Cool. We need an operation contract. We got the thing we missed was the action IDs. So what we're going to do is grab these action IDs from the WSDL, and we're going to go up to our message contracts and paste the actions in there. Make sense? So you see how it all hangs together now? Cool. You done? I bet those angle brackets won't compile. Something tells me. Something tells me, Mike, that we're on a bad path here. Is it all working? Cool. Why don't you see if the damn thing compiles? Wow. Give it up for Mike. Beautiful hand translation of WSDL to CS. Now, we've seen the contract system. Why don't we go ahead and take a look at the next slide? Alt-tab to the slides. It's now time to talk about services. A service is a collection of endpoints that are XML compatible, and they are named. Mike, would you read the haiku?
An endpoint per chance. Address, binding, and contract. That is what matters.
Thank you, Mike. Oh, of course. Give it up for Mike. Mike cannot get enough applause. So, what we're going to do, Mike, originally, had we not gone so long, and if this talk was a little bit longer, we'd actually write the code to use the contract system with the standard I/O mechanism, and actually use contracts on one side and not on the other. But, it's a demonstration for another time. What we're going to go ahead and do now is write a service so we can actually use Indigo for the transport, because the standard I/O thing, it ain't going to scale. It only works on the one node. We're going to need a little bit more. So would you go to the service project? And what I'd like you to do, you want to do this outside of any namespace, by the way. Otherwise, the config will be a lot uglier. What we're going to do is write message, message, star, star. The most important thing you get out of this talk today is message, message, star, star. I'd like you all to repeat it after me. On the count of one, on the count of three, you need to say message, message, star, star. 1, 2, 3. Message, message, star, star. Message, message, star, star. Message, message, star, star. Good, thank you. Message, message, star, star is what we call the universal contract. That is, it is the Indigo contract that accepts any kind of messages input and sends out any kind of messages output. So what we do is we say the request type is message, the response type is message, the action is equal to star, which we special case to mean anything. Agreed? Now, would you write our first Indigo service? We simply need to bundle up our functionality into a CLR type so that we can then expose it through these endpoints. So we're going to implement the contract. Why don't you do some creative cut and paste from main? Cool. Return reply. Looks good. You want to do a little console.write line so we can see the thing's actually working inside of there? Oh, actually, there. We'll get here in a second. Can you go up to the method body? Just do like inside your handle message. Just show us that it's doing something.
Inside of handle message.
Yeah, just like right there. Just print out the action. Cool. So now we'll know that we're actually getting dispatched. So we've got a piece of code. That piece of code is just waiting to be turned into a service, but it's not a service yet. It's simply a piece of CLR code that implements one or more types in our service contracts. To turn it into a service, we have to do two things. We have to figure out how to host it, and then configure it so that it's got these endpoints. Why don't we go ahead and write the 2 lines of code we need to just host it with no endpoints. So service host equals new service host type of process management service. Cool. Host.open, and then do your console write line, read line. So we know it's running. So what we've done is we've created a hosting environment inside of our app domain. And then we've told it to start listening on whatever network addresses have been configured. Now, I could programmatically add some network addresses to here, but what would that do? That would make my software less transparent, because I wouldn't be able to find what addresses this thing listens on. It would make it less flexible, because I'd have to recompile the code to change it. And whether it's closer to the user domain, that's another story for another time. You got it?
Yep.
Cool. So what I'd like you to do now is drag in that app.config file. We're going to go ahead and create an app.config file and configure the service to actually have some endpoints. Cool. Rename it to app.config so the right thing happens. And then open it up. So inside this app.config file, we've got the system.serviceModel section. What we're going to do is create a services element. This is where all of the services get configured to get exposed out of this app domain. Y'all got it? Next thing we're going to do is we're going to add one or more we're going to add the service declaration for our guy. Actually, why don't you use the, okay, fine. Type equals, what'd you call it?
Process management service.
Okay. And I know later on we're going to need some behaviors, which we've got in another piece of config. So can you go ahead and add the behavior configuration? And it is called lap service behavior. Cool. This is the same behavior we used yesterday. Now, the service element lives so that it can be a bucket of endpoints. As my good friend Steve Schwartz says, Indigo's as easy as ABC. An endpoint is an address, a binding, and a contract. You already saw the contract system. An address is just a URL that we can connect to. And then the binding is some configuration information for how the thing's actually going to work. So what Mike is going to do is serve this thing up using basic HTTP binding. Great. And that's great. So we're using the universal contract, basic HTTP binding, and the address. Quickly go to the code. Go to the code. Go to the code. Go to the code. At the end, before you do the console.write line, let's go ahead and print out what addresses we're listening on after the open. So if you can just do a for each endpoint listener in host dot endpoint listeners, and then just do a console.write line. This would be listener.listener.local address. Cool. So did you build it? Why don't you go ahead and start it in a shell window so we can see it work? Yeah, you don't need the piping anymore. That's impossible. I've never seen something like that. A bug in our code?
I have an error in config.
A configuration error?
Lap service behavior. Done.
Scroll to the bottom, scroll to the bottom. There's a behavior down there. Behaviors.
Behaviors.
I said in my mind, if not in my mouth. Thanks. Cool. So the configuration got captured when we tried to open the service. Now, look at you with your debug. Oh, there's service behavior. Oh, you need to rebuild. Thank you, Visual Studio. You edited app.config. That needs to be rebuilt so that it gets pushed back in with the binary. Yay, the service is running. Now, would you bring up another executable, but make a new project, or however you're used to doing it? What we want now is a client application. And what I'd like to do is program against that contract. So why don't you go ahead and bring the contract, bring in Indigo, just like always. We bring in Indigo, and let's go ahead and bring in the contract that we wrote a few minutes ago. So the contract file, we'll just bring in the same CS file. Great. Now what I'd like you to do is write a program. So why don't we go ahead and cons up a request message. So we'll say process, it is list processes message. Request equals new list processes message. Right, this is the request message. And now what we're going to do is go ahead and create a channel. So we're going to need a process management contract. Channel equals channel factory dot create channel. So we're going to go ahead and connect out over Indigo to that guy who's now listening on that network address. And we're going to give it a configuration name called my endpoint. Again, transparency and flexibility. I don't want to bury the addressing information in the IL. I want it in the config. So what I'd like you to do now is make another copy. Go ahead and add the config file. Rename it to app.config. Lovely. Go ahead and crank that guy open. Actually, go get your endpoint from the other one. This is the fun part. So we're going to grab the endpoint that we used on the server, and we're going to paste it into the client. So we're going to say client, and then we're going to paste the endpoint. And we are going to change two things. Well, actually, we're going to change one thing. On the client side, the contract is that strongly typed process management contract that Mike Can translated. Server's still using universal. Remember the intersection? What do we know about the server's Venn diagram? Everything's in it, right? So he'll take anything. The client is only willing to speak this language, but the intersection is not empty, so we have a chance of it working. I have a high probability that it's going to work because Mike's a good guy. Y'all got it? Now, in order to make this endpoint programmatically visible, we give it a symbolic name called my endpoint. Great. Love it. So we've sent the request. Oh, let's send the request now. So go ahead and do async results, lovely, equals channel dot begin request null null. And go ahead and while request dot is completed, do a little magic so we know that thing's still cooking. Great, and now do a system.thread.sleep for whatever you feel like, half a second or something. Great. And now once this thing is done, why don't you go ahead and harvest the reply message. So this will be process listing message reply equals channel.end with the results. And see, once you go ahead and just dump it to the output. Process data p in reply.processes. Go nuts. I'll be Anders. Don't you know hex? Don't you know hex? I invented this format string. Can't you type it, you idiots? Great. Got it. Love it. So is the server running?
The server is still running.
You have another shell window?
Yes.
I'm feeling brave. Why don't you go ahead and just try and run it? The build failed. Hold on. Begin get processes. No overload. Go to begin get processes. When you did the translation, did you get go to the contract file?
Hold
on. This is why we ship service util, because not only is Mike slow, he has errors. So when he set it up to be an async client-side signature, he forgot to do the standard 2 arguments. Cool. Did it build this time?
Yes.
So we're going to run the client, bin debug client. Oh, it got dispatched on the server side. We have an error. Did you get the action URIs?
Demos.
That was our fault message that came back, by the way. Remember Mike had the little if statement? Right? He screwed up the action URI either in the WSDL or in the processing code.
This was all planned to demonstrate that fault.
Yes, we practiced this error so many times to get it just right. It was very hard work.
It's very subtle. It was very nice.
Yes, it was very nice. I love it. Actually, I will now want to see this every time I see this kind of code.
And so it failed because the XE was still running, and I restarted.
Cool. So you start up the server first. Just run the client. Whoa. Mike Vernal, thank you very much. Oh.
Thank you, Don.
Cool. So For the next piece, we're going to talk about identity and security. Don't fall asleep, don't leave. To do this, I'd like to bring up my good friend Doug Walter. Doug, would you come up? Doug does the dev on this team. Give it up for Doug. Doug, do you vow to be a good code monkey, suborn all your?
You have a Bible? I can.
Yes, we need the SDK.
I so do.
Okay, great. Mike, to practice as monkey, would you hit the space bar?
He even gets names wrong.
Did I call you Mike when I should have called you Doug?
Sure did.
Dude, I'm so sorry. He was up here so long, he wouldn't leave. He kept writing the code so slow. You know, when I've seen him type before, he typed so fast, but he just wanted all this stage time. He had typos, the errors. He's such a ham.
I'm going to do the same stuff, I know.
So, the software industry has a long and illustrious track record of keeping the security industry fully employed. By obfuscating the terminology to a point where only someone with a PhD in mathematics can understand it, they have succeeded in creating a whole industry of folks who figure out how to make this stuff secure. That is not a scalable approach. If we really want the planet's software to be secure, everybody's got to be able to understand it or we are screwed. Remember that thing we talked about up front about transparency and flexibility? The other thing we said was it's got to be closer to the domain model. It's got to be simpler and more like the way I think. And we've tried all kinds of stuff. But I got to say, I think we might be on to, I think we might be on the right path. The security model we use across this entire wave of software is based on the notion of a claim. You will hear many people on our team talk about claims-based security. Let's look at the noun. A claim is an XML-compatible assertion that helps establish a digital identity. It's an XML-compatible assertion about something that helps establish a digital identity, that is my presence out in the world. Doug, do you feel comfortable with the haiku?
The haiku?
Would you mind?
It's beautiful.
Would you read it for us?
I will. I'm me. I assert, and if you don't believe me, trust the issuer.
Everything you need to know. Oh, I'm sorry. Give it up for Doug. Everything you need to know about security is in that haiku. I promise you, promise you, promise you. I am me. I have made an assertion. Everything we do in this system has a set of claims, which are these assertions. Trust them or not. I can simply put them in the message. I can simply put them in the data. And you are free to trust them or not. And if that's all we had, it would not be a secure system, because it would be based on trust. We need a system based on distrust. How do I know you're actually you? How do I know you're actually allowed to look at dogs and cats on the internet? How do I know you're allowed to play ESRB-T games? How do I know? I wish I could believe you, Doug, but you've lied to me before. So anything you tell me needs to be verified. It needs to, I need someone to stand up for the veracity of the statement. We call that other person the issuer. And here's a problem. You told me this guy was your issuer. You told me Mike is your issuer.
Okay.
Well, how do I know I can trust Mike? In fact, how do I even know who Mike is?
Well, because he has a badge, and Microsoft said that he's Mike.
Ah, so Mike is only Mike. He says he's Mike. Mike, will you say I'm Mike?
Sure, I'm Mike.
I don't believe you. Mike, do you have your blue badge with you?
Yeah.
Can I see it? If I were at the company, with the office, we could test if a door open to see if this is still valid. And if this were true, then I have to ask myself, can I trust Microsoft? We all know the answer to that. So, Doug, take me to the code. Actually, Ed, take me to the code. We are going to show you the entire security programming model of this whole platform. It's 3 lines of code. Y'all ready? So don't fall asleep. Pay attention. This is the only 3 lines of code you have to know, and it's going to be on the test. All right? Mike, will you, God, we'll stop calling you Mike. Doug. Doug, will you take me to the server? Actually, go shut down everything. Make sure the server's not running, because we're going to have to rebuild it, because we're going to change a little bit of code.
I think they're all shut down.
Cool.
Now.
Go to the server, and before you do anything, what I'd like you to do is find out what claims are available. Find out what we can know in a cryptographically secure way about the sender of the message. So to do that, we are going to reach, get ready folks, it's the moment you've been waiting for. No Dombox talk is complete without going into context. The international symbol for context. In Indigo, the way we do this is we say operation context dot current dot security context, or service security context. This is where the security information hangs off of for the request message. Now, what I'd like you to do is test that guy for null. And if and only if it is non-null, do I want you to do anything. Because if there's no security, this will be null, in which case we don't have any claims. Y'all got it? So if it's not null, what I'd like you to do is go grab all of the claims. So let's enumerate all of the sets of claims. A claim set is simply a set of claims from a single issuer. Mike's a very diverse guy. Mike loves model trains, and he loves Microsoft. There's a lot of things Microsoft loves to say about Mike, and there's lots of... Mike! I'm pointing to Mike. Guys, I got it straight. Doug, Mike. What? Doug, Mike. No problem. Mike works at Microsoft. I don't know if Doug works at Microsoft. I haven't seen his blue badge, right? But I know he does. Mike works at Microsoft, and Mike likes model trains. There's a bunch of claims that Microsoft makes about Mike, and there's a bunch of claims that the Model Train Association of America makes about Mike. And they both might be in the message. Because part of his digital identity is an aggregation across any number of stores. This isn't like centralized, Big Brother crap. Right? It's like everybody says stuff they want, and we just decide whether to believe it or not. So, why don't we go ahead and grab all the claim sets? And for each claim set, there's just a set of claims. These are the assertions, the things we can know. So why don't you just enumerate the claims and just dump them in the output. Cool. Go ahead and start the service up. That's client 1, that's service, so just run it. So we're listening, go ahead and pop it. And notice, what do we notice? We had no claims, because we were using the basic HTTP binding without HTTPS, so there are no claims. What I'd like you to do is kill the service, because we're going to have to change the config. Go to the config, and on the server's config, why don't you go ahead and add a couple endpoints that support a few security protocols. So Control-K, Control-X, WinFX, WCF, let's see, generic jet, that one, and then an info card one. Yeah. So that's going to be universal contract, and mypath/WS maybe. Cool. And then add an info card one while we're here. WinFX, WCF, info card-based service endpoint. Cool. That will be universal contract, and give it like /info card or something like that. Hit escape if you need to. Cool. Great. So you got those endpoints. Why don't you go... Oh, that whole spelling thing. Hate that. Cool. Why don't you go ahead and build it so that it copies the app.config file. It's so annoying you have to do this. And then go ahead and run it in the shell again. Make sure we didn't screw something up. Cool. So notice we're now listening on 3 different endpoints for different kinds of configuration, all in the same contract. Cool. Now, let's go change the client. Go to the client's app.config file, and why don't you stick in the normal WS HTTP binding. So WSHTTP binding basically says generic client endpoint, the top one. My endpoint's the name we've been using. Contract name is whatever it's set up there. I would just suggest copying it, but you're a good typist. Yes, I love it. And then what'd you call it? WS? Great. And we can't have two endpoints called my endpoint, so we got to rename one of them, otherwise it's an error, right? So this is a unique symbol space. Cool. Build the client. Let's see the server run. Now go to the client. Go back to the server. Let's look at the output. We used Windows, by default, WSHTTP binding. This configuration uses Windows auth, which means it uses Kerberos or NTLM inside of WS security. And the Windows security system is exposed to the Indigo programmer. It's just yet another claims provider. It's another issuer. And so all of the group SIDs, all of the privileges, all of the account IDs that I've got show up as NT SIDs in an XML-compatible way. Y'all see that?
So I see that you're logged in here as Don Box. Does that mean I can send an email now?
Yes. Good observation, Doug. I am logged in as Don Box. You can send email as me. Now, go ahead and kill the client. It's dead. OK, great. Now I want you to add one more endpoint, which is the info card endpoint. So on the client side, we're going to reconfigure the client to use info card. And info card gives us a single-click logon that works with credentials either from just the server or across organization boundaries. This is no longer tied to Windows. This is now a plain XML format of credentials that I can share with my partners or other sites on the internet. Did you get it all fixed up? You need to call the server. We're doing mutual authentication. The server certificate is lap service, so that's good. Looks good. Did you rename the other endpoint so you only have one? Cool. Build the client, run the client. Notice we see the lovely InfoCard API, UI rather. That's right, UIs are for humans, APIs are for programs. I have to keep remembering that. Click that info card. It's got our CodeMonkey email credential in there. Go ahead and hit submit. And now if we go back to the shell, notice that the claim that got admitted was the email address, codemonkey.microsoft.com. Make sense? Able to change the way security worked in a flexible manner, never had to change the code. It was pulled out of the code and into an XML format that I could then edit. In fact, we had to rebuild it just because Visual Studio forces the app.config to get copied. Right? Make sense? Give it up for Doug. Last but not least, the one, the only, the man who I've been trying to work with for the past, 8 years now, Dharma? When did we meet? 8 years ago, I finally got a chance to work with the lovely and vivacious, energetic Dharma Shukla. Give it up for Dharma. Let me switch to the video. Actually, no, we need to, first off, do you understand the rules of the CodeMonkey?
Yes.
Great. Are you willing to abide by the rules of the CodeMonkey?
Of course.
Great. Would you be so kind as to hit the space bar? Workflow. Dharma is on the Windows Workflow Foundation team, which is part of our team. What is a workflow? It's an XML-compatible program. It's an XML-compatible program that combines domain-specific activities. Dharma, are you comfortable reading haiku?
Of course.
Would you be so kind?
A XAML runtime. Now you too can be Chris Broom. Is it possible?
Give it up for Dharma. I'm going to switch the video to your machine because we have some build incompatibilities. So we're going to go to Dharma's box. Here's what's going on. Windows Workflow Foundation has taken this notion of separating out the opaque code from the transparent configuration of that code, arrangement of that code, dare I say orchestration of that code. It's taken that separation to the limit and has said there are things that are opaque, there are things that are transparent. And we're going to build a tool set, a runtime, a format, a debugger, as much as we can do to make it so that developers can live in that world where we have an explicit boundary between the opaque code and the wiring up of that opaque code. So what we're going to do is write a little bit of opaque code right now in Visual Studio. So why don't you just bring up a new text file, however you like to do it. There's no better way to get there's no better way to understand WinOE than to write hello world in it. I'm sorry, WWF. Sorry, I will never say that again. Because no one has a WinOE colored beard. So, we're going to need a couple of namespaces using system. And finally, using workflow.component model. This is where the heart of WWF lives. Everything you care about is likely in this DLL. The interesting thing about WWF, and Dharma and I have had this chat several times, I think of it as a meta runtime. It's a runtime that has almost no policy pre-built into it. Rather, the policy is built as these things called activities. And even things we might consider as primitive, as conditional, iteration, sequence, and parallelism are actually not baked into the runtime, but instead built in this component model, so that if you don't like the way we did sequence, write your own. Rip ours out, put yours in. If you've got some existing workflow language like WS Beeple or Beeple for Wuss, whatever name we gave that thing, and you love Beeple for Wuss, rip out our parallel, write one that's exactly like Beeple. Totally fine. We don't care. We're just big tent trying to make your code load and run. Now, we're going to write an activity first. So to write an activity, we simply write a CLR type, public class, write line. Because all console applications in the future will be written using WWF. We're going to derive from the class activity, which is the base class of WWF that tells us how to do this opaque code. And we're going to have a single property called text of type string. Text. You need an X in the field name, dude. Lovely. Now, to make this activity complete, what we're going to do is implement the one method we have to implement. The way the scheduler of WWF causes activities to run is it calls a well-known abstract method on them called execute. So we're going to override the execute method. And execute takes one argument, which is a handle to the runtime. This parameter comes into me, and if I need in my execute to interact with the runtime services and the scheduler and all the other stuff, there's my reference into it. And I have to return a status code. I may elect to do all of the work synchronously in this block of stack frame, or I may elect to let the stack frame disappear and finish the work later on. So the status code indicates that I return whether I've synchronously completed or have asynchronous work pending. And in our case, we're going to be done. Now, Dharma, here's where the business logic of Fabricam goes. Please put it in. Yes, that Fabricam is going to succeed. I can feel it already. Great. Now, if you would be so kind to go to a shell and just compile that sucker into a DLL using God's compiler, csc.exe. There you go. We're done. We got an activity. It'll work in WWF. We can put it in the fancy workflow thing with all the boxes and arrows, or we can load it up and run it. We're done. Right? You now know how to write an activity. Congratulations. Now, what I'd like to do is write some workflow against that. So workflow, unlike that code there, which was opaque, brittle, we're going to write some very transparent and flexible workflow code. So why don't we go ahead and give ourselves a new XAML file. Now, you may notice that we misspelled XAML when we built this damn product. We called it XAML. I don't know what was going on. There was a whole, we were doing the whole, like, Zooml, Zimmel, Zemel, and, you know, these guys, you guys went off and made XAML. It's all XAML. And the syntax that we're going to look at, we don't use the other XAML compiler, we use our own. We are in the process of unifying so that there will be a single XAML by the time we ship this beast. For those of you who are playing with the PDC bits, it's called .xaml, not XAML. And we still use the old school syntax that you may remember from PDC 2003, which means we have a mapping PI. So what we're going to do is bring in, we're going to bind the CLR namespace to an XML namespace. And we're going to tell it what assembly it's in, which is writeline.dll, which don't need the .dll. So there's our mapping PI. What we're going to do is write a workflow. So why don't you go ahead and save this in our directory. Is it in the right place?
Yes.
Cool. Would you be so kind as to write a sequential workflow? Okay. We're in old school XAML, so we're going to say x:class. We're going to define a new type. Whatever you're calling it is fine. I really don't care. We're going to give it an ID, and then we're going to set the default namespace to be the one that is for XAML. I'm sorry, for WWF. And finally, we're going to define the X prefix to definition. Those of you who did Avalon programming 2 years ago are just saying, wow, that looks very familiar. Cool. So we've got all the XML goop set up. Why don't we go ahead and call WriteLine? Well, how do we call WriteLine? It's an activity. We simply say it is a child of this workflow. And so we stick in a WriteLine tag. We give it an ID so that we can refer to it later on if we want to for data binding purposes or what have you. And we give it some text. Cool. We close the tag, we close the string literal, then we close the tag. Thank you, my friend. This XML thing's going to catch on, Dharma, I promise. And it looks like you have an XML problem. Or maybe you don't. You think it's okay?
Yeah, I think so.
Degree of confidence, Dharma?
99.
Okay. Why don't we go back to your shell? And what we're going to do is we have this little program called workflow shell. Is that what we called it?
Yes.
Which basically just loads up the XAML, hosts the runtime, and runs the program, and we're done. So what we're going to do is call a workflow shell with the XAML file and the DLL that we referenced from the XAML file, because it's not smart enough to go find it by itself using the little amount of code we wrote. So why don't you go ahead and hit return?
Yeah.
Give it up for Dharma. Dharma, what can I do with that? Could you write a couple more? Could you like copy and paste that right line or do something? Give me a sequence of those things. So what we're going to do is just have a block of write lines, right? Because our domain, this is where we change the business logic, right? The business analyst came in and said, I need more text, more text. So this is where the technical systems analyst dude comes in and changes the business logic without touching the opaque code. There, you've got your imagination. Fabricam, Fabricam. Okay, cool. You got it? Why don't you go ahead and run that now? Ooh. Now I hear, thank you, give it up for Dharma. Dharma, I hear that one of the benefits of WWF is that it allows me to be much more explicit and transparent about the way I deal with the concurrency of my program. And unless I'm mistaken, you have both sequence and parallel as pre-built or predefined activities, which even if I didn't like, I can use them or not use them, but it turns out they're awfully darn useful. So why don't we go ahead and do some parallelism in our program here. So what we're going to do is put a parallel block. So we're going to fork off the work so we have multiple pieces of code running in concert. And then we're going to fork it into a couple of sequences that are going to run in parallel. Okay? So we're going to just split things across the two branches of code. So we're going to create two sequences. Looks good. Now we're just going to go copy and paste those things under the right place. So what we'll have is the first branch will do 1, 2. The second branch will do 3, 4 in parallel. And the order in which they execute is, at least in theory, non-deterministic. As far as you're concerned, it's non-deterministic. Because the guy who wrote the damn scheduling engine is writing this code. He can tell you exactly what order they will run in on this box. But he's not on your team, so it's useless knowledge. So did you save your workflow?
Yes.
Dharma, would you be so kind as to go back and run that? Ooh. Concurrency was explicit, and it ran in parallel. Would you be so kind as to add a little delay so we can see if we can perturb things a little bit? So there's a built-in activity called delay, which will simply pause execution for a moment. Timeout duration equals 00, you pick your number here. That's 2 seconds, I believe, yes?
Yes.
Great. Go ahead and rerun your program. Wow. Give it up for Dharma. All right, Dharma. If we had more time, we could write more code, but we have to get out of here at any minute, so I'm going to say goodbye and tell people, what session should they come to, Dharma? What session do you think would be useful for them?
Dawn and my Indigo session tomorrow, we call it the Windigo session because it's WWF and Indigo.
Yeah, so Dharma and I are going to show more Indigo and WWF integration. So give it up for Dharma. Oh, no feedback. Finally, to get out of here, what do we know about the future? Well, first off, everything I just showed you is in the future. We haven't shipped any of it yet. By definition, everything I just showed you is in the future. Okay? Just to set expectations. Don't overpromise. We're going to underpromise and overdeliver, right? Instead of the other way, which doesn't work out so well. But what is beyond this? The future, as I see it and a bunch of my friends see it, is that we're moving to an XML-compatible world that supports collaborations between programmers and the rest of the world. And XML is this enabling technology that allows us to tease out all kinds of different semantics from our code to allow us to better live with people who don't know how to program but still want to make software better. You saw it here, all the WinOE demos, I'll talk about the business analyst versus the programmer. All the Avalon and ASP.NET talks about the designer versus the developer. All of the management talks talk about the IT pro versus the developer. We're at the center of the universe. The world is lining up to hang out with us. We are still the coolest people on the planet. And the way the rest of the world will be able to associate with us is through XML. So to close out, I will read the last haiku. Code versus data? Is that really the question? Both must coexist. Thank you very much.